Okay, let's start. So I'm creating a class, a box. I'm writing one method called setData, which take int data as parameter. This dot data is equal to data. Writing another method, say int get data. Now I'm saying return data. So you tell me a class contains variables and methods. Variables are called data members because they are used to hold data. Methods are called member methods because methods use data members to perform operation. Right on. So this is called data member, and these are called member methods. So we have data member and member methods. Is this clear? So this is my class, which one box, and this is my data member, and these are my member methods. Correct? Okay. Now, listen. Now, what I'm doing now, I'm creating object of box class. So box B is equal to new box. So what I'm doing, I'm creating object of which class? Box class. So box class object will be created. Correct? You tell me in box class any instance variables are there or not? There. Which one? Data. So instance variables are created where? Inside the object when object is created. So inside box class object, one instance variable called data will be stored. Instance variable will be stored inside the object. Which one? Data. Is this clear? We have not initialized, so it will be initialized with default value. Then instance methods are right on. Okay. So listen. So this is what. So now listen. What is my? You tell me. I want to create two threads here. How many threads? Two threads. So I want to create two threads. So I want to create two threads, thread 1 and thread 2. Okay. Now listen, I want thread 1. Thread 1 wants to call setData method. Thread 2 wants to call getData method. Suppose we have two threads, thread 1 and thread 2. So we have multiple threads now. Now, thread 1 wants to call setData method of box class, whereas thread 2 wants to call getData method of box class. So my question to you people is, if a thread wants to call the method of a class, what a thread requires? If a thread wants to call the method of a class, what a thread requires? If a thread wants to call the method of a class, what a thread requires? If a thread wants to call the method of a class, what a thread requires? If a thread wants to call the method of a class, what a thread needs or what a thread requires? Suppose I want to call setData method of box class. What I need? I want to call setData method, getData method of box class. So to call setData and getData method of box class, what is required? Object of what is required? What is required? If a thread wants to call the method of a class, what a thread requires? Okay. So if a thread wants to call the method of a class, a thread requires object of a class. A thread requires object of a class. A thread requires object of a class. So if thread 1 and thread 2 want to call the methods of box class, thread 1 and thread 2 needs object of box class. Thread 1, thread 2 require object of box class. So there are two possibilities are there. We can create two objects of box class. Okay, B1, B2. First object we can give it to thread 1. Thread 1 will use first object to call set data method. Second object we can give it to thread 2. Thread 2 uses second object, box class object to call get data method. This is one possibility. Second possibility, instead of creating two objects of box class, we can create one object of box class. Instead of creating two objects of box class, we can create one object of box class, and we can give one object to both the threads. So both the threads, multiple threads can use one object to call the methods. So what I'm doing now, I'm not creating two objects here. I'm creating one object, and I'm giving one object to both the threads, and both the threads will use single object to call the methods. So thread 1 uses box class object to call set data method. Thread 2 uses box class object to call get data method. Thread 2 uses box class object to call get data method. So thread 1 is using box class object to call set data method like this. And here thread 1 uses box class object to call get data method. So both the threads are using single object to call member methods. Methods means member methods. So tell me here I'm allowing how many threads to call the methods on a single object at the same time. Here I'm allowing how many threads to execute the methods on a single object at the same time. Two means multiple. So here I'm allowing multiple threads to execute the methods on a single object at the same time. So allowing multiple threads to execute the methods on a single object at the same time is called as synchronization. Is called as non-synchronization. So what is non-synchronization? Allowing multiple threads to execute the methods on a single object at the same time is called as non-synchronization. Here object is called as resource. So who is called resource? An object is called as resource. So who is called as a resource? An object is called as resource. So allowing multiple threads to execute the methods on a single object, at the same time is called as non-synchronization. Is called as what? Non-synchronization. Is this clear? Here in multi-threading, an object is also called as resource. Who is called as resource? Object. Sometimes instead of saying object, people say resource. Resource means object means resource. Is this clear? Suppose one cake is there, but there are 10 students are there who wants to eat one cake. So I will allow all the 10 students to eat one cake at the same time. What is this called? Non-synchronization. Allowing multiple students to eat one cake at the same time is called as the same way. Allowing multiple threads. Here students are like threads. Cake is like object. Eat is like method. Eat is like method. So allowing multiple threads to execute the methods on a single object at the same time is called as non-synchronization. Here object is called as resource. Who is called as resource? Who is called as resource? Object. Object is called resource. Is this clear? Okay. Now the question is, if we allow multiple threads to execute the methods on a single object at the same time, is there any problem or there is no problem? If we allow multiple threads to execute the methods on a single object at the same time, is there any problem or there is no problem? Let's try to understand, shall we? If we allow multiple threads to execute the methods on a single object at the same time, is there any problem or not? Let's try. Rick, you tell me, variables are called as data members. Variables are called as methods are called as member methods. Why variables are called as data members? Because variables are used to hold data. That's why variables are called data members. And why methods are called as member methods? Because methods use data members to perform operations. That's why methods are called as member methods. Is this clear? So now tell me, see this diagram. I'm allowing multiple threads, not one thread, to execute the methods. Methods means member methods on a single object at the same time, right or not? So this is called non-synchronization. So is there any problem in if we allow multiple threads to execute the methods on a single object at the same time? Yes, there is a problem. What is the problem? Listen, shall I? Who are called as data members? Data members, variables. So see, if we allow multiple threads to execute the methods on a single object at the same time, if object contains if object contains any data, who holds data inside object? Instance variables, which are also called as data members. If object contains any data, then the data is shared between multiple threads. If object contains any data, then the data will be shared between multiple threads. How the data will be shared between threads? You tell me, threads are calling member methods. Methods are called threads are calling methods. Methods are called member methods. Why methods are called member methods? Because methods use data members to perform operation. That's why methods are called member methods. Are you following or not? So threads are using data, not directly through methods. Threads are calling methods. Methods means member methods. Member methods are using data. So if we allow multiple threads to execute the methods on a single object at the same time, and if object contains any data, the data will be shared between multiple threads. How the data will be shared between multiple threads? Through member methods. This is called data inconsistency problem. See how the data will be shared between multiple threads. See, one thread is trying to modify the data. Set data method is modifying the data, na? And get data method is accessing the data, na? So here I'm allowing multiple threads to execute the methods on a single object at the same time or not? So I'm right or not? So thread one is calling set data method, which is modifying the data. At the same time, I'm allowing another thread to access the data, correct or not? So tell me, when one thread is modifying the data, thread should allow to access the data at the same time, should not? Should not. If one thread is modifying the data, other thread should not access the data. When one thread is accessing the data, other thread should not modify the data. Following or not? Answer me. But here one thread is accessing the data at the same time, another thread is modifying the data. So this is called data inconsistency problem. People are following or not? So tell me, so in non-synchronization, see, if multiple threads are allowed to execute the methods on a single object at the same time, and if object contains any data, then the data which is there inside the object is shared between multiple threads, which can lead to data inconsistency problem. So in non-synchronization, there is a chance of data inconsistency problem. There is a chance of data inconsistency problem, which can lead to data inconsistency problem. Are you following or not? So in synchronization, what is the problem? In synchronization, there is a chance of data inconsistency problem. Are you following or not? So there is a chance of data inconsistency problem in non-synchronization. You understood what is data inconsistency problem? One thread is accessing the data. At the same time, another thread is trying to modify the data. So this is called data inconsistency problem. Is this clear? Now the question is, then how to resolve data inconsistency problem? Is this clear? Then how to? If people are following or not? So then the question is, then how to modify how to resolve data inconsistency problem? So the solution is synchronization. The solution is, so data inconsistency problem can be resolved by using synchronization. Synchronization means thread synchronization. If people are following or not? So synchronization means what? Allowing only one thread to execute the methods on a single object at the same time is called as synchronization. So in synchronization, other threads have to wait. Is this clear? So it is something like this. I will take the cake and I will place the cake in the table in the classroom. And classroom is having a law. I will tell all the 10 students go outside the classroom, make a queue. One student student go to enter in classroom, enter into classroom, lock the door. Remaining 9 people should wait outside. The person who entered the classroom, who locked the door, will start eating the cake. Once he completes eating, he will open the lock, come outside. The second student who's waiting will enter and lock the door and start eating. Are you following or not? Meanwhile, remaining 8 people should wait. Once he completes eating, he will open the lock, come out. Third student will enter into the classroom, lock the door, start eating the cake. So like this, one by one student is allowed to eat the cake at the same time. So here I'm allowing how many threads? How many students to eat one cake at the same time? One cake. Once, and they allow making remaining to wait. And every student is allowed to eat the cake. Only one student is allowed by acquiring the law, right or not? So in the same way. Is this clear? So listen. So what is synchronization? See, we have modifiers or modifiers are keywords or we have one modifier called synchronize. Which one? So synchronize is a keyword and a modifier. Synchronize is a keyword and a modifier. Which modifier? Non-access modifier, which is allowed only for methods and blocks. Which is allowed only for methods and blocks. So synchronized is a keyword and a modifier. Synchronized is a keyword and a modifier which is allowed only for methods and blocks. Synchronized keyword is allowed only for methods and block. A method which is declared by using synchronized keyword is called synchronized method. A method which is declared by using synchronized keyword is called as synchronized method. And a block which is declared by using synchronized keyword is called as synchronized block. A method which is declared by using synchronized keyword is called as synchronized method. A block which is declared by using synchronized keyword is called synchronized block. So tell me, this method is declared by using which keyword? So this method is a which method? Synchronized method. Are you following? And see this block. This is block. This block is declared by using which keyword? So this is called which block? Synchronized block. So synchronized is a keyword and a modifier which is allowed only for methods and block. A method which is declared by using synchronized keyword is called synchronized method. A block which is declared by using synchronized keyword is called as synchronized block. So in Java, using synchronized keyword, we achieve thread synchronization. In Java, using synchronized keyword, we achieve thread synchronization. So how we can achieve thread synchronization in Java? In Java, using synchronized keyword, we can achieve thread synchronization. We achieve thread synchronization by using synchronized keyword. Shall we? So listen. If we declare a method or a block of a class, if we declare a method or a block of a class by using synchronized keyword, then the method are following, then the thread who gets the CPU, then the thread who gets the CPU will acquire the lock of an object, for executing synchronized methods and synchronized block, for executing the synchronized methods and synchronized block. Meanwhile, other threads have to wait. To execute synchronized methods. Is this clear? To execute synchronized methods and see, if we declare a method or a block of a class by using synchronized keyword, then the thread who gets the CPU will acquire the lock of an object for executing the synchronized methods and synchronized block. Meanwhile, other threads have to wait. To execute synchronized methods and synchronized block. Are you following? Meanwhile, other threads have to wait to execute synchronized block methods and synchronized block until the thread who acquires the lock releases the lock. Is this clear? Until a thread who acquires the lock releases the lock. Is this clear, everyone? If we declare a method or a block of the class by using synchronized keyword, then the thread who gets the CPU will acquire the lock of an object for executing the synchronized methods and synchronized block. Meanwhile, other threads have to wait to execute synchronized methods and synchronized block. Meanwhile, other thread execute synchronized methods and synchronized block. Executing synchronized methods and synchronized block. Meanwhile, other threads have to wait. Meanwhile, other threads have to wait until a thread who acquires the lock releases the lock. Are you following on? Answer me. If a thread acquires the lock of an object, when it releases the lock after the completion of synchronized methods and synchronized block. If a thread who acquires the lock of an object completes the execution of synchronized methods and synchronized block, releases the lock. Then one of the waiting thread who gets the CPU will acquire the lock of an object for executing the synchronized methods and synchronized block. If a thread who acquires the lock of an object completes the execution of synchronized methods and synchronized block, releases the lock. Then one of the waiting thread who gets the CPU will acquire the lock of an object for executing the synchronized methods and synchronized block. So how many threads are allowed to execute synchronized methods and synchronized block? Only one thread by acquiring the lock of an object. Meanwhile, other threads have to wait. So this is called synchronization. Are you following or not? So waiting threads means, a thread who has acquired the lock of an object is executing synchronized methods and block. Remaining threads are waiting. So waiting threads are not allowed to execute synchronized methods and synchronized block, but waiting threads are allowed to execute non-synchronized methods and non-synchronized block. What do you mean by non-synchronized methods and non-synchronized block, which are not declared by using synchronized keyword? Waiting thread cannot execute synchronized methods and blocks, but they can execute non-synchronized methods and blocks. Are you following or? So synchronize is a keyword and a modifier which is allowed only for methods and block. A method which is declared by using synchronized keyword is called synchronized method. A block which is declared by using synchronized keyword is called as synchronized block. If we declare a method or a block of a class by using synchronized keyword, then the thread who gets the CPU will acquire the lock of an object for executing the synchronized methods and synchronized block. Meanwhile, other threads have to wait until a thread who acquires the lock releases the lock. If a thread who acquires the lock of an object completes the execution of synchronized methods and synchronized block, releases the lock, then one of the waiting thread who gets the CPU will acquire the lock of an object for executing synchronized methods and synchronized block. Waiting threads are not allowed to execute non-synchronized methods and synchronized block, but waiting threads are allowed to execute non-synchronized methods and non-synchronized block. Is this clear, everyone? I hope everyone understood this. Shall we move on to next one? Let's do one thing. Let's take this example. Which example? Assume a new movie is released on Book My Show. Only one ticket is available. Remaining all are sold out. Now there are 10 people are there, 10 who are trying to book one ticket, one movie ticket. So they will send the request to Book My Show application. Book My Show is a web application running inside web server. What is web server? We will see later. And that web server is running on server machine, which is connected over the network, where our machine is connected. From our machine, we use browser or we use some app, Book My Show app, to send the request to server to book one ticket. Actually, 10 people are sending the request to server to book one ticket. So what will happen? Server will create 10 threads, and those 10 threads will call one method of Book My Show application. Which method? Book ticket. And 10 threads are trying to book one ticket out now. So here, if multiple threads are allowed to book one ticket, what happen at the same time? Multiple people can able to book one ticket or not. At showtime, multiple people will come to watch movie, right or not? But seat is only one. Are you following or not? So this is called data inconsistency problem, and this is called non-synchronization. So how we can avoid this problem? By using synchronization. So we should allow only one student to book one ticket at the same time. Remaining should wait until he completes the job. This is called synchronization. So let's try this example, shall we? So see, I already have written the code. See, I've written the code. Listen. So I have created a class here. What is the class? Book My Show. I have created a class whose name is Book My Show. Is this clear? See, shall we? I'm creating a class, say Book My Show. Inside this class, what is this? Instance variable, available tickets. How many? One. And this is one instance method. This is called data member. This is member method. Member method uses data member. So book ticket. And it is having one parameter into wanted tickets. And this is the member method which uses data member. Is this clear? Answer me. Okay. Now I will explain this code later, but before that, see. Listen. Now, how many threads I am going to create? Multiple threads now. So I will create two threads. Child thread. So I'm creating thread 1, extend thread, override run method. Thread 2, extend thread, override run method. And I want both the threads to call which method? Book ticket method or Book My Show class. So tell me, if a thread wants to call book ticket method or Book My Show class, what a thread needs or what a thread requires? Object of book my show class. And I want to create two objects and give it to both separate threads, or I want to create one object and give one object to multiple threads. One object I want to create. So how is it possible? By using composition, by using, composition. In composition, one class object has the reference of another class object. So in thread one class, I'm creating the reference variable of book my show class as a instance variable. PMS is a reference variable of book my show class. I'm creating as a instance variable in thread one class. So in thread one class object, this instance variable is created. And to initialize this instance variable, I'm using one parameterized constructor. Which constructor? To initialize instance variable, I'm using parameterized constructor. So at the time of creating object of thread one, we need to pass which class object? Book my show class object. At the time of creating object of thread one class, we have to pass book my show class object. Are you following on? And this is run method. And inside the run method, using book my show class object, I'm calling which method? Book ticket method. Who execute run method? Thread. Which thread? Child thread. If we call other method from run method, who will execute that method? Thread only. Useless. Main thread will execute main method. Child thread execute run method. If we call any other method from run method, who will execute other method? Child thread only. So I'm passing one. In the same way, in thread 2 class also, I'm creating book my show class reference variable as an instance variable. And to initialize this instance variable, I'm writing one parameterized construct. At the time of creating thread 2 class object, we need to pass book my show class object. And then I'm overriding which method? Run method. And inside run method, using book my show class object, I'm calling book ticket method. Which method? Book ticket method of one. Book ticket method of one. Is this clear? So who will execute run method? Child thread. Child thread. From run method, I'm calling which method? Book ticket. Who will execute book ticket method? Child thread. Then what I'm doing in main class, I'm creating how many objects of book my show class? Only one object. I'm creating thread one class object by giving book my show class object. I'm creating thread 2 class object by giving or passing book my show class object. So one object I'm giving to both the threads. See, we have constructor now. So I'm passing book my show class object to the constructor. So both the threads are using one single object. Now I'm setting the name of threads. T1 dot set name first person, T2 dot set name second person. Then I'm calling T1 dot start, T2 dot start. Now both the threads I'm executing. Now both the threads are executed. Executed, not executed. Execute. Right or not? Now tell me, both T1 thread, T2 threads are having same priority, different priority. Same priority. So who will get the CPU first? We can't say. Who will come a complete first? We can't say. Assume thread 1 will get the CPU. Assume. Now thread 1 will get the CPU. If thread 1 gets the CPU, thread 1 will execute run method. From run method, thread 1 will execute book ticket method by passing 1. So book ticket method will be executed. What is wanted tickets? At the time of calling the book ticket method, we are passing 1 now. So who will receive that one wanted ticket? Now who is executing book ticket method? Thread 1. Now I'm getting the reference of currently executing thread object. Who is currently executing thread object? Thread 1. I'm getting the name of that thread 1. What is the name? First person. What is the name? First person. I'm displaying the name. First person is trying to book the ticket. Then I'm checking if condition. Who is executing this code? This method? Thread 1. Wanted tickets 1, available tickets 1. 1 less than equal to 1, condition true. Enter into body. Check. Now in the body, I'm displaying one message. Wanted tickets, how many? 1 is allotted to first person. Then printing the tickets. Are you following? Then I'm calling thread.sleep method. I'm just calling it for 1 second. Now my thread 1 will go to sleep for 1 second. Are you following or not? For 1 second, it will go to sleep. Is this clear? You tell me, thread switching happen anytime, any place or not? So thread switching can happen at first line also, second line also, third line also, anytime. But assume thread switching happen here. when I call sleep method. So who will, right or no? Who is waiting? Thread 2 is waiting. Thread 1 is executing. Now once the thread switch here, when I call sleep method, thread switching happens. Assume thread 1 will go to waiting. Thread 2 will execute. Are you following or not? Now thread 2 will get the CPU. Who will get the CPU? Thread 2. Thread 2 will execute run method. From run method, thread 2 will execute book ticket method. This method, book ticket method. What tickets are how many? One. I'm getting the reference of currently executing thread object. Who is that? Thread 2. I'm getting the name of the thread. What is that? Second person. I'm displaying. Second person is trying to book the ticket. I'm checking if condition. Second thread. Right or not? 1 less than equal to 1. Condition true. One ticket is allotted to second person. Then printing the ticket. Thread switching can happen anytime, any place. Assume thread 2 call sleep method. Thread switching happen again. Then which thread is waiting? Thread 1. So thread 2 is executing. Thread 2 will go to waiting. Thread 1 will get the CPU. It will execute. Last time thread 1 executed this line or not? It will execute this line from here. From here it will start. Are you following? So tell me 1 minus 1, 0. Available ticket 0. Comes to body here and display. Available ticket 0. Now thread 1 completed the execution of book ticket method. Thread 1 is dead. Thread 2 will get the CPU. Thread 2 will start from available tickets here. 0 minus 1. Available tickets are already 0. One ticket is 1. 0 minus 1 minus 1. Then comes to here. Display available tickets minus 1. So how many threads are allowed to book, execute book ticket method here? 2 thread, multiple thread. And how many people are trying to book one ticket here? 2 people. Are you following or not? So this is called data inconsistency problem. So say this. Let's try. Tell me Java C synchronization example. Java synchronization. See what happened? First person is trying to book the ticket, thread switching happen. Second person trying to book the ticket, thread switching happen. One ticket is allotted to second person, printing ticket, thread switching happen. One ticket allotted to second person, printing tickets, thread switching happen. Available tickets for first person is 0. For second person, minus. So one ticket is booked by 2 people. This is called data inconsistency problem. Are you following or not? Answer me. And this is called non-synchronization. We are allowing multiple threads to execute the methods on a single object at the same time. This is called non-synchronization. So in non-synchronization, we have data inconsistency problem. Are you following or not? So how we can resolve data inconsistency problem? We can resolve data inconsistency problem by using synchronization. By using synchronization, we can resolve data inconsistency problem. So tell me, synchronize is a keyword and a modifier which is allowed only for methods and block. A method which is declared by using synchronize keyword is called synchronize method. A block which is declared by using synchronize keyword is called synchronize block. Answer me. So if we declare a method or a block of a class by using synchronize keyword, then the thread who gets the CPU will acquire the log of an object for executing the synchronized methods and block. Meanwhile, other threads have to wait until a thread who acquires the log releases the log. Are you following? Once a thread completes the execution of synchronized methods and synchronized block, a thread releases the log. Then one of the waiting thread who gets the CPU will acquire the log for executing the same synchronized methods and block. Are you following or not? Answer me. So how we can achieve synchronization in Java? By using synchronize keyword. So here both the thread 1, thread 2 executing which method? Book ticket method. Run method. From run method, which method? Book ticket. So let's declare this book ticket method of book my show class by using synchronize keyword. We achieve synchronization in Java, correct? So tell me, I'm declaring the method of book my show class, book ticket method by using synchronize keyword. So it is called synchronize block method. Then the thread who gets the CPU will acquire the lock of which class object? The thread. Suppose thread 1 gets the CPU. Then thread 1 will acquire the lock of which class object to execute synchronized method book ticket? book my show class object. Because using object, they are calling the method. Now, so a thread will acquire the lock of book my show class object to execute book ticket method. Are you following or not? Now thread 1, then meanwhile thread 2 should wait until the thread completes the execution. Are you following? Until the thread releases the lock. When thread 1 will releases the lock after after executing the synchronized methods, right or not? After completing the synchronized method and block, a thread releases the lock. Are you following or not? So tell me, first thread will execute, right or not? Then first thread complete, then child thread, second thread 2 will get the CPU. Thread 2 will execute. But here our one tickets, 1, available tickets 0, condition false. So it will display of tickets sold out, 0 tickets are available. Are you following or not? So say this, compile and run. See who got the CPU? First thread. First thread will acquire the lock. Lock of which class object? Book my show class object. To execute book ticket, which is a synchronized method. It is executing. Now book the ticket or not? And tickets are available 0. Now completed. First thread releases the lock. Then second thread who gets the CPU will acquire the lock. And it will start executing book ticket method, synchronized method. Second person is trying to book the ticket. But tickets, condition false. Available tickets, falling or not. So this is called synchronization. So how many threads are allowed here? Only one thread to execute book ticket synchronized method book ticket by acquiring the lock. Remaining threads are waiting. Understanding or not? So we have used synchronized method, synchronized block, synchronized method. Is this clear? So now the next question is, in synchronization, is there any problem? Yes, there is a problem. Synchronization increases the waiting time of threads. Synchronization increases the waiting time of threads, which will impact the performance. Synchronization increases the waiting time of threads, which will impact performance. Is this clear? So if there is no specific requirement, don't use synchronization. If there is any specific requirement, then only use synchronization. So how synchronization increases the waiting time of threads? Listen. For example, we have declared book ticket method by using synchronized keyword or not. Assume in book ticket method, 1000 lines are there. How much? Assume 1000 lines are there. So how many threads are calling that book ticket method? 2 threads, T1, T2. Actually, thread 1, thread 2 will call run method. From run method, they are calling book ticket method. Correct or not? So assume thread 1 will get the CPU. Suppose thread 1 gets the CPU. Thread 1 will execute run method. From run method, thread 1 will execute book ticket method by acquiring the lock. Correct or not? And it will start executing. How many lines are there in this method? So thread 1 will releases the lock after executing 1000 lines. After executing 1000 lines only, it will releases the lock. Meanwhile, thread 2 should wait. Are you following or not? So this is the problem with synchronization. Synchronization increases waiting time of threads and impact performance. Is this clear? Now, how we can resolve this problem? See, we can reduce the waiting time of thread. By reducing the lines of code, so inside that synchronized method, 1000 lines are there. So thread 1 who gets the CPU will acquire the lock of book my show class object for executing the 1000 lines which are there inside synchronized method or not. So 1000 lines are taking 5 minutes to execute. Suppose till that time, thread 2 should wait or not. We can reduce waiting time of threads by reducing lines of code. But how to reduce lines of code? By using synchronized block. So see, instead of using synchronized method, we can use synchronized block. Why? To reduce the lines of code. So suppose I don't want to make the whole method by using synchronized keyword. Are you following? I want to write only 100 lines. Total 1000 lines are there. I want a thread to acquire the lock of book my show class object for executing only 100 lines. but not 1,000 lines. And other threads have to wait until the thread execute 100 lines to acquire the lock. Are you following? Meanwhile, waiting threads can execute 900 lines, but they cannot execute 100 lines at the same time. When they can execute? When the thread who acquired the lock releases the lock. Are you following or not? So we can reduce the waiting time of thread by reducing the lines of code by using synchronized block. So I have removed synchronized keyword from method. Now let's identify some lines of code and write inside synchronized block. So I want to write only this if condition. Which one? This if condition inside synchronized block. Remaining code I don't want to write. Tell me. So how to write synchronized block? Use synchronized keyword first. Write parenthesis. Listen, a thread will execute synchronized block by acquiring the lock of an object. So a thread should acquire the lock of which class object to execute synchronized block? A thread should acquire the lock of which class object to execute this synchronized block? Book my show. Here, book my show is which class? Current class. So use this. This means current class object. Who is current class object? Book my show. So a thread who gets the CPU will acquire the lock of current class object to execute this synchronized block. Are you following or not? A thread will acquire the lock of current class object to execute this synchronized block. Are you following or not? And assuming this synchronized block only 100 lines are there. So a thread who gets the CPU will acquire the lock of bookmyshow class object only to execute synchronized block, which contains 100 lines. Waiting threads cannot execute 100 lines, which are in synchronized block at the same time, but they can execute the code which is there outside synchronized block at the same time. Are you following or not? Answer me. So this is how we can reduce the waiting time of thread by reducing the lines of code by using synchronized block. So say this, still it will work. Since see, first person is trying to book the ticket, one ticket allotted, printing. Second person trying to book, available ticket 0, ticket sold out, available ticket 0. Only one student is able to book, one person is able to book that ticket or not. You run once again, see. You will not get data inconsistency problem. People are following what I'm saying now. So this is what synchronization, non-synchronization and synchronization. Okay. So before moving to next one, listen. You know, there are two types of lock a thread can acquire. In synchronization, a thread will acquire the lock of an object or not. In non-synchronization, will not. So there are two types of lock a thread can acquire. The first one, object lock, and the second one, class lock. There are two types of lock a thread can acquire. Object lock, class lock. Object lock is also called as object level lock. Class lock is also called as class level lock. So now the question is, when a thread will acquire the lock of an object, you don't need to call instance method object is required or not. But to call static method object is not required. So listen, if a thread will acquire the lock of an object, if we declare instance methods of a class, by using synchronized keyword. A thread will acquire the lock of an object if it declare instance method of a class by using synchronized keyword. A thread will acquire the lock of an object if we declare static methods of a class by using synchronized keyword. Because to call static method object is not required. We can call using class name. But to call instance method object is not required. To call instance method or class name is not, we cannot use it. We must need object. Is this clear? So when a thread will acquire the lock of an object to execute the method, if we declare instance method by using synchronized keyword. A thread will acquire the lock of an object if we declare static method of a class by using synchronized keyword. I hope you're following this. Everyone. And one more thing. If a thread has acquired the lock of an object, means we can say a thread is the owner of the object. If a thread has acquired the lock of an object means we can say a thread is the owner of the object or a thread is monitoring the object. If a thread has acquired the lock of an object means we can say a thread is the owner of the object or a thread is monitoring the object. Are you following or not? If a thread has acquired the lock of an object means we can say a thread is the owner of the object or a thread is monitoring the object. If a thread has acquired the lock of an object means a thread is called as owner of the object or a thread is monitoring the object. Are you following or not? In non-synchronization, as multiple threads are allowed to execute the methods on a single object at the same time. So in this case, an object is said to be, in this case, an object is said to be not thread safe. If multiple threads are allowed to execute the methods on a single object at the same time, an object is not thread safe. But in synchronization, only one thread is allowed at the same time to execute the methods on a single object. So in this case, an object is said to be thread safe. When an object is said thread safe, if only one thread is allowed to execute the methods at the same time. When an object is not thread safe, when if multiple threads are allowed at the same time to execute the method. In synchronization, an object is thread safe, not thread safe. In non-synchronization, not thread safe. I hope you understood this. Understood, everyone? Answer me. Some assignments are there, you have to try this. So one of the assignments is you have to try daemon thread. What is a daemon thread? What is starvation? First, what is deadlock? Then what is starvation? And the last one, interrupt method. These four concepts you try as an assignment. What is daemon thread? What is deadlock? What is starvation? And what is interrupt method? What is interrupt method? Is this clear, everyone? Answer me. So now I want you people to try this. You have to explain what is non-synchronization. What is the problem with the non-synchronization? What is synchronization? How we can achieve synchronization with one example. I've taken book ticket, ticket booking, right? You take some bus ticket booking or online counseling seat booking or flight ticket booking. Up to you. Try that. Once you complete, 5 minutes complete, then we'll start collection framework. Collections framework. Or simply collections, we can say. We'll start collections. Try. What is non-synchronization? What is the problem with the non-synchronization? What is synchronization? Okay, with one example. Non-synchronization and synchronization. So let's talk about the last chapter, collections framework. Collection framework. Collection framework. So collections framework. Listen. So first we need to understand what is a collection. So first let's talk about what is a collection. Then we'll see why we use a collection. See. So what is a collection? A collection is an object. A collection is an object. And a collection is used to represent a group of other individual objects as a single entity. A collection is an object, and collection is used to represent a group of other individual objects as a single entity. What do you mean by this single entity? I will draw a diagram and I will explain you. Okay, what do you mean by group of other individual object and how to represent a single entity? After discussing what is a collection, then I will discuss what is collection framework. Then we will see something called. I will introduce arrays. I'll tell you the disadvantages of arrays. Then advantages of collection. Then I will introduce all the collections which are available. Okay. So we'll do one thing. We will continue from here in the next class. Okay. Time is over. Can leave.